with ETHDEV. He developed the protocols that make the P2P part of Ethereum work. He's worked on the security protocols. He is someone who has been there since the beginning of Ethereum. He knows it inside out and is still one of the people guiding its development. Ladies and gentlemen, he is also, and I'm telling his secrets here, recently relocated to set up his home base right here in Hong Kong. So ladies and gentlemen, let's have a big welcome for the man who's coming to make his home here, Alex Leverington.
Thank you.
All right, go get him, Alex.
Okay. So I'm going to do something very different. I brought notes. Very quickly, Andrew, thank you for the introduction. Andrew's stage presence is amazing. So, yeah, he pretty much covered who I am and what I'm about. So I'll dive in. Now, I tried to create a title as controversial as possible because that sells tokens. No, I'm just kidding. But blockchain is actually controversial. And I think one of the reasons Nick is so interested in this is because of that. A lot of people might not know, but there's actually a movie that Nick is in. It's called Banking on Bitcoin. I saw it on the plane last month. And if you really want to see what he's about and kind of a lot about Bitcoin, you can see that. But a lot of Bitcoin is about money. And so this presentation is about what we can do that is not concerning money. So this talk, how many people want to create their own tokens? Nobody, just a few people. I was at a conference a couple days ago, EdCon in Toronto, and there was a question. How many people have cryptocurrency? Ether, Bitcoin, something, some token. Okay, can you leave your hand up? Can you leave your hand up if you have cryptocurrency? Now, this is a big deal. Now, put your hand down if you would still have that cryptocurrency if it was controlled by a centralized database or authority. Like, would you still have the cryptocurrency? Put your hand down if you would sell the cryptocurrency. Like, yeah, I don't think people would have the cryptocurrency if it was controlled by a centralized system. So this is weird because it's kind of an elephant in the room. We don't know what to do with it, but intuitively, this is something that we're kind of holding on to and grasping. Next slide somehow. Okay, graphs. There's one word for this slide, and it's unicorn. Here we have the performance of server and network I/O, and what is this, global IP traffic and storage growth. This is how Intel and the computing industry and software industry has gotten so big and been so profitable over the last couple decades. Between Moore's law and Metcalfe's law, you have this effect where basically you take a piece of technology and you figure out how to make it scale exponentially, either the user base or the performance. And when you do that, you try and figure out how to capture value from that pipeline or from the ecosystem that comes from it. And the interesting thing is that blockchains sort of combine these two. There's been a lot of controversy about ASIC hardware for mining, but what may not be realized is that those companies are really actually innovating the silicon and IP process. So Bitcoin and Ethereum mining algorithms are really creating competitors to Intel, AMD, NVIDIA. And so that's interesting. And that gives a little bit of insight into the potential of these technologies. Ubiquity, I think, is a good word for this. So briefly, I want to go over what Ethereum is and why it's become to be important. I think everybody knows what Bitcoin is. I hope. If not, check it out. There's a lot of overviews on how it works. Bitcoin gives consensus about value transfer. So if you want to transfer funds from point A to point B to point C, it does this with integrity, and it also makes sure that if there's Alice and Bob, and then if Alice pays Bob, Alice can't also pay Jill with the same amount of money, right? Jill and Bob can verify that Alice only sent the money to Bob. So that's what Bitcoin does. What Ethereum does, though, is that it provides generalized consensus about state transition. So we have the beginning state and the end state. And instead of providing consensus, and consensus is basically the network agreeing on some information, instead of having consensus on the value transfer, you get consensus on the state transition. So how's the data changed between point A or block A and block B? And that's what makes Ethereum different. And that's also what enables us to build things on top of Ethereum, which either emulate other systems or is not limited to value transfer. All of the ERC20 tokens are a perfect example of this. That provides a value transfer system that is built on top of Ethereum. But Ethereum doesn't care about the tokens or the value transfer. It's also a peer-to-peer network, which is excellent, and it's permissionless and open source. These two aspects are what make public chains disruptive. Historically, if we look at the financial system, if we look at governments, if we look at any large institution or organization that's handling accounting, they're probably using IBM. Maybe they're using mainframes from the 70s. Maybe they're using Oracle. They are using software that is proprietary, that is not accessible to everyone, and this also moves very slowly. However, it's very important to emphasize software from companies like IBM is everywhere. It really does run the financial system. And public blockchains challenge that. Safety, this technology is generally safe, and it's generally safer than existing centralized software systems. I put probably there as a joke. I meant to remove it so I don't scare anyone. That's a joke about cryptography. So the mathematics that back everything relies on probabilistic. So it's probably safe for the next quadrillion years, or until the sun, burns out. Okay, so this is kind of a recap of just what I just went over. So here's the old system, and we have accounting, and we have some software, and some money, right? So there are people, and they count the money, and they enter it into the software. And then there's some organization here that kind of sort of gates that ledger, and we transact through those organizations. And this is blockchain. So we have with Ethereum, we have a state transition system, so we can write little pieces of code that handle the accounting and then manage the state. And then logically or virtually, money is built on top of that. So we get the same thing, but the difference is we have state in a database. We do not have organizations which are regulated by states, which is interesting. The origin of the word state and how we're using state for data, very interesting. But it's a pretty big difference, and this is what is disruptive. So going back to the first slide about like things which scale and why that creates unicorns, this is going to be why this technology really has an impact, because of the properties that it provides. And the result of these properties is trust. Trust in a system that is not owned or controlled by a given individual or corporate body. Ideally, what this is going to do is allows us to do more faster at larger scales. So more people, more activities, and when we have software systems that more people can rely on at the same time, we can hopefully get more things done faster. Okay, I wanted to cover a lot in this presentation, both general and kind of technological, and also encourage people to build in this space. So that's why there's this really complicated thing here. Okay, so what I'm trying to say here is that basically I think we've kind of got the consensus thing figured out. There's an elephant in the room here, right? There's a lot of ICOs, and we don't know if those are legal. How many people have done an ICO? Are you here? Yeah, creating your own magic internet money. That's amazing. So we do have some people doing that. I think the consensus part we've kind of got covered. We've got a ton of research and development going on there all over the world. Same thing with services and utilities. So there's a lot of utility tokens out there that are intending to build a system that's going to provide a generalized service. It could be compute, it could be data oracles, a lot of things where these services are something that new applications will depend on, and the user shouldn't ever actually touch them. People in general shouldn't have to touch a compute system, right? They shouldn't have to go and buy tokens for some compute utility. That should all happen in the background. And what I'm excited about, and where I think we are today, is starting to build applications. And there's a saying that necessity is the mother of all inventions. So I want to encourage everyone here to look into building or supporting or joining the efforts of some application that's going to build in this space, and something that's specific and solves a problem for people, not something that is a service or a layer or utility or something like that, but actual software applications that let you do things that people want to do normally. Normally, people do not want to perform computations. So, right, and if you're going to do that, the question is, what do you need to look into with blockchain technology? Like, what do you need to be doing and looking at so that whatever you're building is going to be a little different, and actually leverage this technology to provide something new? And the two things to look at are one-way hashes and digital signatures. So those are the two things for now, where what you'll probably be doing is taking some existing piece of information, and you're going to create a reference to that information in the form of a one-way hash, and then you're probably going to sign it, and then somewhere along the lines put it in a blockchain somewhere, a blockchain or a smart contract. There's a lot of systems out there for this, state channels, Plasma, Polkadot. There's a lot of new technologies coming up that are going to help you scale, but if we solve the scalability problems, which we will, it does no good if no applications are ready. So generally a new decentralized application, a DApp, is going to take existing systems and data and wrap it up with some kind of references that provides authenticity and integrity, and then push that up to a blockchain so that you can interact with multiple parties with complete trust. That's the goal. Here are some tools you can Google if you want to look into what's coming. Okay, what can you build? A lot of things. So I tried to pick the kind of both lowest hanging fruit, but also something practical. These are things you can do with a blockchain. And before blockchain, you could not do this without people. Now, with digital signatures and one-way hashes, you can do these things and not have people involved. Now, you're going to want to have people involved to audit it and to provide, preferably like academics, PhDs, provide as much information as possible that the system you've actually built actually provides the guarantees and integrity that you advertise. Certification, this could be legal professionals. This could be some state facilitating something that's regulated by the state. Notaries is obvious. You want to stamp something, documents. Voting, cryptography allows us to implement voting algorithms which are secure and sort of tamper-proof. Nobody knows what the outcome is until the vote's over, and so nobody can really kind of try and sway one thing or another. Registration for ID cards and things like that. I don't know if anybody saw the testimony with Facebook in the US, but the software that we can build hopefully solves all the problems that are put to question in that testimony. Okay, so these are some things which, if you are looking into getting into blockchain, these are kind of buzzwords, but when we see mature solutions for these particular pieces of functionality, we will see some real traction towards blockchain. Nobody's going to notice it. It's not going to be a big thing. Oh, wow, like the internet runs on blockchain, or everybody's using Facebook, or everybody's using WhatsApp. It's not going to be like that. It'll be quiet and subtle, and the world will just slowly, we will ideally all begin to trust each other more, and the hope there is that that will lead to more cooperation. If a software system faults and we're all trusting it, we can blame the software. In the US, they might put the programmer in jail. I don't know. I hope not. But as far as the rest of the world, that generally doesn't happen, and I really expect that to continue in the US. But the point is when there's a fault, the fault will be in the software. It's not going to be in an organization. It's not going to be in a state. And we can all work together to fix that bug and improve things. Okay. I don't know how much time I still have, because the timer, do I really have 9 minutes? Okay. I don't know. There's a timer here, and I'm not sure if it's 9 or 5 or whatever.
You're good. You're good.
Okay. Are there
You have time for a
questions?
little bit
I
of
can
Q&A?
look on the app. Yeah. Yeah. What? 5 minutes? I think a Q&A would be good, because there's too much to talk about. It's really broad.
All right, ladies and gentlemen, if you want to put your hands up, we're going to use the app a little bit later, but if you want to put your hands up now and you have a question for Alex, I got one right over here. I've got a young man ready to run a microphone over to you. Here he comes. He's on the move. There you go. He's hustling now. Watch him go. Okay. There we go. Hand up. Another hand up in the room. We'll have another guy with a microphone get you ready.
Hello, my name is Katerina. Thanks a lot for the presentation. Here. No, more.
To your right, to your right,
there.
to your right.
I'm waving at
The lights are very bright up there.
Sorry.
Maybe I shall stand. So thanks a lot for the presentation. Actually, I have 2 questions, so I apologize for jeopardizing the time. The first question is about performance, because to my understanding, there is a lot of performance issues still with the mining. And if all internet is based on blockchain, what about the performance and basically all the electricity generation and so on, so on, so on? And my second question was about mining as well, and the questions raised today that we have mining farms which are concentrated into the hands of just basically two companies, and we are close to a state where we will achieve 51% being done by one party. So basically all the system could be broken. Thank you.
Yeah, so there's two things there. One's performance, the other is mining. I'm not a fan of the proof of work mining, but academics the world over agree that like the one-way hash mechanism, the sort of brute forcing of a hash for mining is it's a very elegant solution to the problem. It is not an efficient solution to the problem. It's very wasteful. So for us to create something as secure as what the proof of work provides is very hard, because what proof of work relies on is it relies on the fact that everybody does not trust everybody else. And so there's basically this lottery that determines who the next leader is. And that's how proof of work works. So for us to replace that, we need to replace it with something that is as fair as the ubiquitous access to electricity. And that's really hard to find. So I do think there will be solutions to that, but they're very complex. So not only is it difficult for us to prove that the solution that we have is as effective or as elegant as proof of work, but then it also has to be implemented, and it must be implemented perfectly. It must be implemented bug-free. So this is why this is why this is taking so much time. As far as performance is concerned, there is what we have today, and there's what we have in the future. And today, you can run everything on AWS. So what we're going to see this year is, I think we're going to see a lot of interim solutions to performance where you can use one-way hashes and digital signatures to authenticate all of the operations of software. And you only post to a blockchain once every 5 minutes or once every 10 minutes. And the reality is generally, if you have software, you really only want to put the critical stuff in the blockchain that is not only critical between parties, but it's critical for a lot of parties over time, because that's what the blockchain's good at. So we are going to get more performance by creating mini blockchains or side chains or whatever, where you have a small set of dedicated users, and the information is only shared among those users. And for those users to trust each other, you take a snapshot of that and put that in the main chain at some interval. So this is how scalability is going to be addressed in the short term. In the long term, I think we have a long ways to go, but we can still get a lot of transparency and functionality out of what we have today. So what I'm trying to say is we shouldn't wait for scalability, because it's going to be better to build these new software solutions sort of in anticipation of scalability than to kind of wait and be like, yeah, I have this great idea, but I'm just going to wait because of scalability. I don't think it's worth waiting, because the other aspect is, if you go and build some software application and it relies on, and it's decentralized, it relies on blockchain, and you put together an engineering team that does a good job of that, that engineering team could help move along in the progress as far as scalability is concerned. So, okay, great questions. Any others?
Last one down in front here.
Okay.
Hi, Alex. On your last point, you said everybody puts trust in the software, and if it faults, it's the fault of the software and not an organization. But if that's the case, then who's held accountable?
Well, that's like asking who's held accountable if a self-driving car kills someone, which is a really serious topic. And so this is, I think this is a part of why the open source and public aspect of these permissionless aspect of these systems is important, because if something fails out in the open and it's all open source, we can all look at what happened and move on from that. In contrast, if we have some derivative system or something that's very closed and proprietary, it gets really big fast, and that fails, it's a black box. So in both cases, like, I think that artificial intelligence, and in this case, permissionless blockchains, maybe nobody will be at fault. I don't know. I'm not an attorney, but I think that that's going to be a important topic over the next 5 or 10 years. I want to know too. So, okay.
All right, ladies and gentlemen, we are running a little bit behind time, and I'm going to get the last question because it came from somebody through our app, Alex.
Okay.
We got a question. It's an easy one. It's not a lawyer question.
Okay.
It's going to be an easy one for you. But ladies and gentlemen, I told you earlier that Alex is moving to Hong Kong, and this is the first time I've worn this hat. I promise I washed my hair this morning. So Alex, I got a little gift for you. I'm going to let you wear this hat while you answer the question from Aiden Sullivan coming through the app. Alex, why did you move to Hong Kong? Aiden, where are you? There you go, out there. Thank you. He's got a question. Why did you move to Hong Kong? Last one.
Yeah, 2 main reasons: food and the business environment.
All right.
So,
and taxes? We always like to talk about the taxes. Yeah, I mean, not so much food, right?
I'm an American, so I'm like screwed either way. It doesn't really, like.
Ladies and gentlemen, let's hear it for Alex Leverington. All right, thanks, Alex. That's brilliant, man.